Hi everyone. So today we are going to discuss one of the most popular sorting algorithms, that is selection sort. Okay. So selection sort basically is it is little bit of advancement on bubble sort. So bubble sort is one of the most inefficient algorithms we have, and we have discussed bubble sort in our earlier lectures. And this selection sort is bit of advancement to bubble sort. Okay, so how selection sort works, let's dive into that. So in this video you are going to see the basic concept of selection sort. Also we are going to see the Python implementation of it. Okay, so first we are going to identify in selection sort. First we are going to identify the minimum element in the list, and once you identify the smallest element in the list, we used to place it to the first location. Okay, and whatever element is there in the first location, with that element we used to swap that element. Okay, so swap it with the element in the first position. So first position will be occupied by the minimum element in the list. That is our first priority. Second is that once you place the minimum element of the list to the first position, the second iteration, the second most minimum element will be picked up, and that will be placed in the second position of the list. That means that will be swapped to the second element of the list. Like that things will go on, and then the third minimum will be picked, and then fourth minimum will be picked, and it will get the corresponding locations and will swap. So this process has to be continued until the list is sorted. Now selection sort is a good algorithm. However, the disadvantage is that if the order of the input element is in worst case scenario, then this sorting algorithm performs poorly, and the time taken by this algorithm is quadratic. That means big O of n square. Okay, so from a diagrammatic point of view, you can look at it. You can see that this is the input we have. So this is the minimum element we have. So this element has to be placed here. So we will swap this element with 8. So 8 will come over here at one position, and 1 will be occupying the first position. And in the second iteration, we pick 2. 2 will be placed here in this position, and 4 will come to 2's positions, and third iterations 3 will be picked up. Like every iteration will be picking the minimum element. So first 1 has been placed here in the first position, 8 has gone over there in the last position, and the second case 2 has been picked and it has been placed in the second position. So every time you are picking the minimum. So first thing, the most important thing in selection sort is that every time you have to pick the minimum element. Okay, so 3, now next 3 will be picked up because 3 is the minimum after 2. So 3 has been placed. So this gray area, you are seeing that these all elements are sorted in ascending order. Okay, 4 and then 6 and then 8 and then 9. So this is how selection sort works. So at the end you will get the sorted array. Now let us see how this can be implemented in Python. Let us assume that let us take that this is our input in a list. So this is the outer loop. So first what we will do is the definition of selection sort. What we will do, we will first take the length of the list, which we will store in number. Okay, this is the length of the list because length is important. 1 2 3 4 5 6 7. So 7 is the list, is the length of the list. First time, suppose minimum is the minimum element of the given list. So that means let us assume that the minimum element is the minimum element of the given list, and let us assume that first element is the minimum element. So this is j. So this j, which is the first element, has been stored in minimum variable. Okay, so our assumption is that 8 is the minimum element. Now what we will do, we will keep checking it. We will scan the list from 4 to 1. We will scan the list, and first 4 and 8 and 4 will be compared to each other. Okay, so this will happen, this minimum equal to j. So this is 8, So j plus 1 onwards it will go. So whatever the index of it is, if it is 0 in 0th index, so it will go from 1 to the last index. That means 1 to 0, 1, 2, 3, 4, 5, 6 until 6 it will go. This loop will go from 1 to 6, because if the first index is 0, it will start from 1, 2, 3. So in terms of, so minimum element is 8. So this one, this 8 will be compared to k. Now what is k? K is this element, second element. So 4 will be compared with 8. So after comparing 4 and 8, we have seen that 8 is larger than 4. So 4 is minimum. So new minimum will be having. So we'll lose the minimum. We'll lose the minimum which we thought that it would be 8, but it is not. 4 is the minimum. So minimum will become 4. So next time it will be 4, and then with 6, 4 and 6, 4 is still the minimum. So k won't be changing. Then 9, 4 and 9 will be compared to each other. 4 won't be changing. 4 still the minimum. Then 2. Once it encountered with 2 will be the minimum. So we'll lose the earlier minimum, which was 4, right? So 2 is the minimum. Now this 2 will be the minimum. So next 2 and 3 will be compared. 2 and 3 will be compared. 2 is still the minimum, and 2 and 1 will be compared. 1 will become the new minimum. Once it is becoming the new minimum 1, then what will happen? This loop will exhaust, obviously, because this is 1. This loop will be exhausting, so it will come out of the loop. That means the inside loop will be exhausted, so it will come out of the loop, and here one swapping will happen. With which the swapping will happen? So first we are going to store this j value to t. That means we are going to store the minimum here, the earlier minimum, which was 8, and then the new minimum is nothing but 1. So 1 will be so this 8 will be overwritten by 1. So r1 is the new j value, and this t, which we earlier was thought that 8, which we thought the minimum, that will be occupying this value's mean position. So that means first vj will be written into t in the temporary variable. So minimum is nothing but vj. This j is nothing but 8. And so finally we will be getting the minimum as 1. Okay, minimum and 1, and that means 8 and 1 will be swapped. This whole swapping part, swapping snippet will just do what? It will just will bring 8 over here, 1 over here, and 8 over there, right? So this is what happens. So this is, so we can see that first in the first j value, the outer loop, the first index has been placed in the first index position. The minimum value has been placed. Now the remaining array is this one. So that means next our minimum will be assumed to be 4. So then 4, and then this remaining this list will be scanned together, and out of this remaining array or list, whichever is the minimum will be placed over here. So here the minimum is 2. So in the next iteration 4 will come over here and 2 will be placed over here, right? This is how this loop will occupy. So it is like this. Next 3 will come, then after that 4 will come, after that 8 will come, after that 9 will come. So finally you will get the results. Let us say what will be the, let me run this. So this is the result you will get: 1 2 3 4 6 8 9. Okay, this is the result. So this is what the selection sort algorithm is. So it's quite easy. It is just a modification of bubble sort algorithm. In bubble sort also similar type of things happened, but only thing is that in bubble sort, this whole, because in bubble sort we are just bubbling the greater element and we are pushing it, and we are keeping it in the last position. That means the largest element occupies the last position, but that happens in by default fashion. So in bubble sort, what happens? In bubble sort also similar thing happens. Only thing is that in bubble sort, the greater element, the largest element in the first iteration, it used to get the last position, and the second pass, the second largest element get the second last position. Like that things happened, but that was not specific. But in selection sort, we are forcing the minimum element to occupy its first position, then second minimum element to occupy the second position, third minimum element to occupy the third positions, things like that. Okay, so the time complexity of selection sort algorithm is O of n square, as we have two loops over here. This is the outer loop, this is the inner loop. So this loop can consume maximally n, and this loop can consume also maximally n. So n into n square. Okay, so each iteration from here, each value of j, this inner loop works for n times. So there are at most can be n numbers over there, because the size of the list is n. So n into n square. So big O of n square is the time taken by the selection sort. So I hope you have enjoyed the video of this selection sort, and many more sorting algorithms will come in future. Thank you for watching.